Welcome to the Crazy Hat Chemist. So today we're doing another video in bonding. So let's get moving. Bam! Today we're talking about drawing a Lewis dot structure number 7. And today we're going to be drawing the Lewis dot structure for phosphorus pentachloride. Now, phosphorus and chlorine are both nonmetals, so it does have a prefix, and that is a helpful hint for you as well. So there's one phosphorus because there's no prefix for it, because you don't need the prefix for mono. And then penta is the prefix for what number? That's right, 5. So just like the pentagon. So it's phosphorus pentachloride, just like that formula right up there. So now you're going to find a periodic table, hopefully one smaller than you got right up here, and you're going to get the valence electrons for phosphorus and for chlorine. So the valence electrons for phosphorus is 5. The valence electrons for chlorine is 7. And how many phosphorus? 1. So I'm going to multiply that 5 times 1. And then how many total chlorines in this formula? There are 5. So I'm going to multiply the chlorine, the 7 valence electrons, times 5. And then I'm going to sum these two numbers up, and I'm going to get 40. This is the total number of electrons. And like I have done in all the other videos, I'm going to divide this number by 2 so that I get 20. Now this is 20 pairs of electrons, not 20 electrons, but 20 pairs of electrons. Alright, so now I have the 20 pairs of electrons. Now what we're going to do is we're going to find the least electronegative element of the two between phosphorus and chlorine. Now remember, the most electronegative element is fluorine. So I'm looking for the element that is furthest from fluorine, but never hydrogen, but that's not an issue here with this one. So phosphorus is the least electronegative element. That's why it goes in the middle. Now I'm going to spread the chlorines around the phosphorus. Now, here's a little note here. There are actually 5 chlorines, and normally the phosphorus and all other central elements go for an octet rule, but phosphorus happens to be period 3 or greater. It's in period 3. So if it's in period 3 or greater, it can be hypervalent. That means it can exceed the octet rule. And that's why all the phosphorus are equal distance around, all the chlorines are equal distance around the phosphorus. Okay, and you don't have 2 chlorines bonded to each other. Some people have done that. Don't do that. Okay, now what we're going to do is we're going to place a pair of electrons in between the central element and the outside elements. I have done that like such. Then you're going to place the lone pairs of electrons on the outside elements like this. Okay, I'm going to make a circle around these elements here, and I'm going to verify the octet rule. Remember, the octet rule is for 8, like an octopus. And that is fine for chlorine. Chlorine follows the octet rule, so it must have an octet. Then I'm going to circle around that phosphorus, and you should have recognized this already, and I did mention it already, but phosphorus is hypervalent, meaning it can exceed the octet rule. It can exceed the octet rule because it's in period 3 or greater. Remember, when I say period 3 or greater, I don't mean above on the periodic table. I mean below, period 3, 4, 5, 6, 7. Period 3 or in number-wise and greater. All right, now what we're going to do is we're going to clean up this Lewis dot structure, draw lines for bonding pairs of electrons, leave the lone pairs of electrons as dots, and then we're going to have this beautiful structure right here. All right, hopefully that works out well for you. You should see that beautiful structure. That's what we're looking for right there. All right, that was another Crazy Hat video by the Crazy Hat Chemist. And thank you very much, Richard, for this hat. I love it. It's a cool hat. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I will see you next time. Bye now.